Okay, we've been working with making models of atoms for the past couple of days, focusing on the arrangement of the electrons inside those atoms. So we're going to do one more example real quickly of tellurium. Okay. Tellurium is in the 1, 2, 3, 4, 5th period and 1, 2, 3, 4, 5, 6th group. Okay. So we have tellurium. And yes, you have to be writing this down. Is in the 6th group. Remember, a group goes up and down. In the 5th period. Okay, highlight it again on the periodic table. Tellurium is right there. What that means, I'm going to start with my nucleus. And because we're in the 5th period, we have 5 energy levels, or 5 shells. Both of those are correct terms. 2, 3, 4, and 5. I'm going to use orange for the electrons. Because we're in the 6th group, that means we have 6 valence electrons. And remember, the valence electrons are found on the outside shell. So 1, 2, 3, 4, 5, 6. Okay. Now to fill in the core electrons. Remember, the core electrons are all the ones inside, not valence. On the first, we can only ever have 2 electrons. I'm going to make my electrons a little bit smaller so it doesn't get too chaotic. On the second shell, we can only have 8. 2, 3, 4, 5, 6, 7, 8. The third shell is one of those tricky shells. We have to look at tellurium's position on the periodic table again. If it's after these, then on the third shell it will have 18 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. The fourth shell can also be kind of weird. But again, we're after this middle section here called the transition metals. Since we're after those, the fourth shell is also going to have 18. Making a total of 52 electrons. That's a lot of work, especially if you consider the fact that the ones that are important for chemical reactions are only these valence electrons. So what I'm going to show you now is a shortcut. And the shortcut goes like this. And that's it. This is called the Lewis dot structure. All the Lewis dot structure does is it shows only the valence electrons, only the electrons important for chemical reactions. And yes, you have to write that down. So all you have to do is write the chemical symbol, find how many valence electrons there are, and draw the valence electrons around the chemical symbol. For example, if we were to do lithium, lithium is Li. Lithium is in group 1 of the periodic table, which means it has 1 valence electron. So I draw 1 valence electron, and that's it. As a personal preference, whenever I'm drawing electrons, I always start at the top and work my way around, one at a time, until I get back to the top, and if I have more than 4, then I pair them up. Okay? For example, if we were to do oxygen, oxygen is in the same group as tellurium, which means it's in group 6, which means it has 6 valence electrons. So I draw 1, 2, 3, 4, 5, 6 valence electrons. And that's it. We'll do one more quick one. Xenon. Is in group 8 on the periodic table, which means it has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And that's it. Now I want you to work on the handout. If you don't finish in class, it will be homework due on Monday. And if you need any help, message me on Schoolology. Have a good weekend.